Hey, today I am going to explain how Instagram improved HDR video on iOS using Dolby Vision. This is the story of why HDR Reels originally looked wrong, how missing metadata caused those issues, and how Meta engineers fixed the entire video pipeline end to end. This is a story about video quality, system design, and performance at scale. First, we'll look at what users actually experienced when HDR Reels were broken. Then we'll explain why metadata is essential for HDR video to work correctly. Next, we'll walk through Instagram's video processing pipeline and identify where things failed. After that, we'll cover the challenges of playback on iOS, the early fixes that didn't scale, and the much bigger Dolby Vision problem. Finally, we'll look at the complete solution and the lessons engineers learned. HDR support already existed on Instagram, but the viewing experience was inconsistent. Users noticed something was wrong even though HDR was technically enabled. This made the problem difficult to diagnose and easy to underestimate. HDR reels often looked incorrect. Some videos appeared too dark, others looked too bright. Many felt uncomfortable to watch. The problem was most noticeable in low-light environments, especially at night. Users couldn't explain the issue clearly, but they could feel it. And that confirmed the problem was real and widespread. HDR is not just about better pixels. Displays need instructions to know how to render HDR correctly. Those instructions come from metadata. Metadata tells the display how bright the image should be, how colors should be mapped, and how the video should adapt to its environment. Without metadata, HDR cannot work as intended. On the iPhone side, HDR capture works correctly. When an iPhone records HDR video, it embeds Dolby Vision metadata directly into the file. This metadata includes brightness, contrast, color information, and ambient viewing environment data, also known as AMVE. At capture time, HDR video is complete and accurate. Instagram enabled HDR support in 2022. However, the implementation was incomplete. During server-side processing, critical HDR metadata was removed. As a result, HDR context was lost before videos reached users. Metadata defines how HDR content should appear on screen. It controls brightness, adapts video to room lighting, and preserves accurate colors. When metadata is missing, HDR becomes unreliable. Without metadata, the same HDR video can look completely different. Displays lose guidance on brightness and color mapping. This is why losing metadata effectively breaks HDR. Instagram's video pipeline has three main stages. First, video is captured on the iPhone. Second, it's processed on Meta's servers. Third, it's played back on iOS devices. HDR depends on all three stages working correctly. At the upload stage, everything works perfectly. iPhones upload full quality 10-bit HDR video. Dolby Vision and AMVE metadata are fully intact. No problems occur here. The problems begin during server-side processing. Instagram does not serve the original uploaded video. Instead, every video goes through a processing pipeline. Instagram transcodes videos to support different devices and network conditions. Multiple versions of each video are created at different bit rates and formats. This ensures smooth playback globally, but it also adds complexity. This processing happens at massive scale. Millions of videos are transcoded using FFmpeg. Formats include S, DR, VP9, and AV1. At this scale, small limitations in tooling can cause major issues. During transcoding, the video frames survived. The HDR metadata did not. FFmpeg lacked proper support for Dolby Vision and AMVE metadata. As a result, HDR lost the instructions needed for correct rendering. The final playback stage on iOS made the issue very visible. iOS relies heavily on metadata to render HDR correctly. iOS supports Dolby Vision and AMVE. Instagram uses a low-level video renderer for Reels playback. But without metadata, even the best renderer cannot produce correct HDR output. HDR frames were arriving without brightness instructions or environmental context. Displays had no guidance. That's why videos looked too dark, too bright, or visually uncomfortable. This was not a hardware problem. iPhone cameras worked correctly. iOS displays worked correctly. The failure happened entirely in server-side video processing. Engineers began testing quick fixes to improve HDR playback. Engineers noticed AMVE values were consistent across frames. They hard-coded those values during playback. HDR visuals improved immediately. But this was only a temporary workaround. Hard coding. Metadata is fragile. Future operating system updates could break the fix. Android devices do not support AMVE. This solution could not scale. The real solution was preserving metadata end-to-end. Meta added AMVE support to FFmpeg. Logging and validation ensured metadata survived the entire pipeline. AMVE was only part of the problem. Dolby Vision introduced a much larger challenge. iPhones record Dolby Vision using HEVC. Instagram does not deliver HEVC at scale. So Dolby Vision metadata had to be migrated to AV1. VP9 cannot carry Dolby Vision metadata. AV1 Profile 10 can. Engineers had to extract metadata from HEVC, transfer it to AV1, and preserve it accurately. Solving this required ecosystem-wide collaboration. Meta worked with Dolby, FFmpeg, Shaka Packager, and AV1 teams. Multiple tools across the pipeline had to be upgraded. Even after that, iOS did not automatically support AV1 with Dolby Vision. Engineers manually injected metadata into the video renderer. HDR playback finally worked correctly. Once implemented, the solution went through extensive validation and testing. Dolby verified brightness accuracy, color mapping, and adaptation to lighting conditions. Visually, HDR was finally correct. The first A/B test produced surprising results. Visual quality improved, but user engagement dropped. Watch time decreased. The issue was performance. Dolby Vision metadata added about 100 kilobits per second. That slowed video startup. Users left before playback even began. The goal became clear: preserve HDR quality and restore fast playback. Dolby compressed the metadata from 100 kilobits per second to 25. There was no visible quality loss. Playback speed improved dramatically. Meta built custom FFmpeg compression. Client-side decompression was added. Around 2,000 lines of new code were written. The second A/B test was successful. Playback was fast. Watch time increased. HDR quality, especially in low light, was excellent. In June 2025, Dolby Vision HDR rolled out to all iOS users. Instagram became the first Meta app to support Dolby Vision on iOS. This project revealed important lessons about large-scale video systems. Metadata must be treated as first-class data. End-to-end pipelines must preserve both video and metadata. Performance matters more than peak quality. Distributed systems are more fragile than they appear. Dolby Vision nearly failed not because of visual quality, but because of performance. Compression and careful metadata handling made HDR work the way it was always meant to on Instagram. This story shows that great engineering isn't just about adding features, it's about understanding the full system from capture to playback and respecting the invisible details that make everything work. If you enjoyed this kind of technical storytelling, hit subscribe, share it with a fellow engineer, and drop a comment with what you want me to cover next. See you in the next one.